Hello, ladies and gentlemen. We're going to start off with Chapter 1 in the supplemental text, and we're going to talk about some things you should have learned in middle school. So this is kind of a refresher lecture, and actually this unit to the next couple of weeks is going to be a refresher for some of you guys. So just bear with me, and we'll start off now. So first, what's matter? This is going to be the first question on Edpuzzle. So I want you to write down a definition of what you think is matter. And the next slide we'll go over it. But first, for you, just to let me know what you're thinking. Any answers right. What's matter? So you've done that. Matter is a substance that occupies mass and volume. It has mass. It's something tangible. Mass is material substance matter that you can weigh, you can feel, you can touch if it's big enough. It occupies a volume. It means it has 3 dimensions to it. So we've got this matter, and we have a mass and occupies volume. Now this matter could be a whole bunch of things, small things, together that we can see, or it could be large. It could be very, very, very small. And in fact, we're going to talk about the smallness of matter in terms of chemistry. So this is what we're looking at. So not only are we going to talk about matter, but we're going to classify matter. In this chapter, we're going to talk about how to classify matter. So first, we're going to look at the different types of properties. And there are many properties that matter has. And we're going to classify them in very distinct types. And a lot of matter has all of these properties. So what we're doing today is just kind of letting you know how to classify things. One way to classify matter is based on extensive and intensive properties. So extensive properties is basically a property that is dependent upon how much you have. Mass is an extensive property. Volume is an extensive property. How much heat can be absorbed is an extensive property. So it's all dependent upon the matter, how much you have. Intensive is independent of the amount you have. For example, temperature. For example, a lot of chemical properties are intensive properties because no matter how much you have, it's going to do the same thing. So we've got basically 2 types of extensive and intensive properties. So now we're going to, whoops, wrong way. We want to identify matter. How do we identify what we have? This is the way science works. We take measurements, we make observations. And so what we do is when we have matter, we got to identify it. And we do it one by physical properties. And we do something to measure it, and so we're not changing the composition. So whatever we do to the matter to measure it, we're not changing the composition. So color, is it a gas? Is it a liquid? Is it a solid? When does it melt? Basically go from a solid to a liquid. When does it boil? Go from a liquid to a gas. Does it conduct electricity? All these are physical properties. And here's a chemical property. Its ability to change itself. So when we have a chemical property, we're looking at how the substance can change from the matter can change from one substance to another. Something's either being added or taken away. And this is what I mean by chemical property. And it basically, does it react? Does it burn up? Can it undergo what we call oxidation? Give or take electrons. Flammability, which is different from combustion. So always, as you notice, I highlighted always changes in red because in a chemical change, matter always changes. And that's something you need to realize that, whenever we have a chemical change, we're looking at the matter is gaining or losing other elements. Now, we're going to look at how chemical and physical properties change. We'll talk about the definition of reversible later, but physical change is mostly reversible. Sometimes it's not, but most of the time it's reversible. So when we're looking at a physical change, we're looking at, say, we're adding mass, going from changes in phase, going from a solid to a liquid, does not mean we have a chemical change. If we know that at a certain temperature we get a phase change, that's a physical change. However, when we have a physical change due to a chemical change, most of the time it is not reversible. There are some exceptions to these rules, but for the most part, any physical change due to a chemical change is not reversible. And that's something we need to realize. Now, reversible can go either way. So if you take ice, melt it to water, then by adding heat, then take away heat to get it back down to ice, that's a reversible physical change. Now, there are some times when a physical change is irreversible. Say like taking a candy bar and dividing it into two. We're not changing the composition of the candy bar, but we can't stick it back together. So that's one of the type of physical change that's irreversible. We're not changing the chemical, it's not a chemical change, but I dare anybody try and put back a candy bar without any other additives, like glue. So this is what we mean by a reversible change. Now when we have a chemical reaction, we're looking at basically a change in a physical property for the most time. For example, when I have aluminum and add hydrochloric acid onto aluminum, we'll put it in some water, we'll add a little bit of acid to it, the aluminum is going to bubble. It's going to produce bubbles. But the water will get warm a little bit, but it won't get to the boiling point of water. That gas that's being produced is actually hydrogen gas. It's not water. It's not water vapor. So that's a clue for a chemical reaction. If we see a change in temperature, again, that's we're not adding any heat. We just put two solutions together and it gets hot or cold. That's a clue for a chemical reaction because we do not expect if we mix two beakers of water together, we're not going to get any change in temperature or color or anything, or change in odor. But if you've got two chemicals and you put them together and you see a change in temperature, change in color, hey, something happened. That's a chemical reaction. And most of the time, especially for this chapter, it's irreversible. I take two chemicals, I get a yellow solid. I can't break up that yellow solid and put it back into two containers. It's irreversible. A reaction has occurred. This is what we mean by looking to see if we have a chemical reaction or not. Now let's figure out how to classify matter. When we look at classification of matter, we got to look at some properties and say, okay, this is how we're going to separate matter into different groups. Chemistry occurs, and the fun part about chemistry is like, oh, this compound doesn't fit any groups. What's going on? And it may be based on reactivity, it may be based on color, all that stuff. Everything how we will classify further. And we want to know how matter fits. So we have general groups of classifications. Not everything fits well into each of these sections, but that's the fun part of chemistry, is figuring out why it doesn't. So let's look at pure substances. When we have a pure substance, it basically has uniform chemical physical properties. So we look at something, it's basically uniform. We can't tell there's anything else in there. Brass is a pure substance. Iron is a pure substance. Stainless steel is a pure substance. Salad dressing is not a pure substance because it can be separated. Oil has a different color than water. It's like, olive oil is slightly yellow. Water is clear, transparent, colorless. And so, when you mix it up, you get a uniform solution, but then it separates. So within pure substances, we actually have two different groups of pure substances. One is an element. Any pure substance can be made of one type of atom. And so we got a list of abbreviations here. We'll talk about those later in the chapter, but Al is aluminum, Fe is iron, O is oxygen, C is carbon, H is hydrogen. And all those are basically elements. It's a pure substance. Because no matter what part, you have a whole chunk of carbon, we divide it up, the chemical and physical properties of each section, of each group, of each part is going to be the same. Now, a compound is something that's made of two elements combined. So we have a substance like sugar. It contains carbon, hydrogen, and oxygen. That's sugar. Then we have carbon dioxide. It's a compound. Carbon and two oxygens. So that's a compound. It's basically two or more elements combined together. Now, that's a pure substance. So we've got pure substance and divided into two elements and compounds. Now next we have mixtures. Homogeneous and heterogeneous. A homogeneous mixture has a uniform appearance. You can tell it's one phase or one thing throughout. Milk can be a homogeneous mixture because it has milk, it has water, milk has water, fat, proteins, all this stuff together as in one thing. You can't tell there's any other phases. Heterogeneous is you got two or more phases or things in there. You can have a chocolate chip cookie. You got the cookie, the dough, and you got the chips in there. So you can actually say there's two different things in the cookie. That's a heterogeneous mixture. So again, uniform throughout, uniform in appearance, and not uniform in appearance. It's a good way to explain this. Now, let's go ahead and look at the difference between compounds and elements. Properties of the compounds are very different from the elements. When we look at sodium chloride, sodium is a very reactive gray solid and it's poisonous. You eat sodium, you'll die. Chlorine, a very reactive gas, is also poisonous. You breathe in chlorine, you die. Sodium chloride, the reaction of when you add sodium chloride together, it actually burns, it produces heat, and you end up with this white powder called sodium chloride or table salt. It's a nice white tasty powder. People use it on food, and it's needed for human survival. So this is the problem. And so the property of the compounds is largely different from the elements, and this is important. So now, to finish up this lecture, if the substance has a fixed composition, we know it's a compound or an element. If the substance has a very decomposition as a substance, within the substance is going to be a mixture. And we'll take another view of this. If a substance can be physically separated into different compounds, it's a mixture. If not, it's a compound. And a question for you. Is water from a tap a mixture or a compound? And you think if it is a mixture, how would you separate it? This is the end of the lecture for the first week. Thank you guys, and we will see you later.